Hello guys, this is the follow-up video about my project. The project is devoted to XYZ translation motorized stages. I'm using closed-looped MKS Servo28D controllers via RS485, and I assembled the stages, 3 linear stages, using some 3D printed parts. It's not ideal, but at least this is what I was in disposal of and I could make it. Also, I struggled a little with cable management. Maybe it's not the best, but I use multi-core cables. I'm here in Abu Dhabi and I couldn't get easily multi-core cables. I just sacrificed some USB-C power delivery cables to make it happen. Okay, and I'm just testing because in fact this will be used for inscribing in glass using femtosecond laser some structures, waveguides, nanogratings, stuff like this. I know this is very budget. One of the reasons of this project is like to test what is the kind of minimal budget for this kind of things. What else? I developed software which just G-code I generate in Skype using G-code tools code extension, and I have G-code prepared with some kind of Mach-Zehnder structures that I want to test it. Like, don't spend time in the optical lab. It's better to test everything in desk of my home or office, whatever. Okay, let's test it. I started the procedure. Let's see what will happen. One issue that I overlooked with this stage, this combination of stages, is that I cannot apply linear interpolation, linear in terms of the drawing the line using two axes together, because I cannot synchronize, because I'm not using any MCU. I'm just sending the commands via RS485. Like how kind of mitigation plan, I can divide like too many steps and a line, angled line, and it's slow, but it can make it. In future, maybe I will consider using the step direction mode, using some microcontroller in future, or some 3D printer board. But for simple testings like this, it's enough. Okay. It's not the fastest, but at least in the final realization I'll be using, of course, order of magnitude different distances. It will be much faster, or the mechanical quality will be so bad that it will be not useful for any micromachining, laser micromachining applications. We will see. I just noticed that there are on the market this kind. No, I'm not saying cheap. It's about, I cannot say that it's cheap controller. Each Servo28D PCB cost about 100 of dirhams. It's about, I don't know, like $25 US dollars, something like this. It's not so cheap. TMC 2208 is or 9 is much cheaper. But the thing is that it's closed loop, you never lose any step. It's operated in FOC, field of control, yes, I think, mode. Some advanced, most advanced, I would say, if it comes to the stepper motors. Mode of operation. I'm quite close to move this to laser laboratory to check what it will looks like using laser and single micrometer precision. It comes to the pen, and some imperfection of lines are mostly due to the thing that the pen is, it's regular pen. It sometimes gives more friction, less friction, and I noticed that there is also leveling issue due to this 3D printed part. Most likely the level of the surface of the paper is not constant along like severe places. Oh, this is quite big mistake here. In fact, even it's not mounted the base, it's just lying on the paper. If the friction is higher, it can move all the fixture. Probably this is the reason of this mistake here. Okay, looks like almost finished. Yes, finished.